Welcome to the final session of the day. I hope you've had a fantastic Sharkfest, virtual Sharkfest. I will say this more than once, kudos to Sherry and Angelo, Jasper, and the rest of the team for pulling this off and dealing with things like that just happened. I can't get into the Zoom for my session, and I couldn't even do an audio call on Discord. It's all good stuff. It's all fun. It makes you feel alive. So, my name is Kary Rogers. I work at Riverbed Technology. I came up in tech support, solving, like hard customer problems with WAN optimization and applications, the entire stack, 1 through 7, I had to troubleshoot. And before that, I was a system and network admin. Did lots of monitoring. I wrote an entire network monitoring system with Perl and MySQL and SNMP and RRD tool back in the early 2000s because we were a Mississippi State institution and didn't have any money to buy anything. But I got lots of great experience. But when we had problems, I had all these graphs I could create, any port in the entire network. CPU, traffic utilization, 5-minute polling. I struggled to solve the problems when professors would say, hey, at 3 o'clock in the afternoons, things are slow trying to update grades or whatever it is. We would pull up some graphs, kind of look at it. Many times well, it kind of went away. Great. Let's pretend that never happened. My Wireshark usage was troubleshooting DHCP, looking at the options being sent, troubleshooting multicast. Oh, the TTL's 1, that's why it's not working. Things like that. But really diving in didn't happen until I had to, working at Riverbed, and it was kind of the only way to really solve some of these hard problems. That's kind of what I found, is that you really need a driving reason to have to get into this stuff. That's true for me. All right, I get interested in a lot of things, but unless I really have a reason I need it, I'm probably not going to put in the effort. And I needed it for my job, and I learned Wireshark, and I really liked it. I think some people, people take to this kind of troubleshooting thing, the attention to detail, the curiosity. Curiosity is the biggest part of it. Being curious to figure out what's going on. Anyway. And now, I'm in management. I do this for fun with our Sharkfest folks and my little website called packetbomb.com. I moderate the Wireshark subreddit. It's a disaster. I don't know if that's my fault. Maybe it is. I'll talk about that later. So what we're going to do is talk about a couple of case studies. I did these very early on when I started doing live streams during lockdown. So if you've seen them, that's okay, because really, the point of a case study, while it's satisfying to find the conclusion and go, that was it, that's nice. Today in the Packet Doctors, we had three case studies, and they really solved all 3 of them, and that is satisfying. But that's not the point. The point is not to just go from A to B as quick as we can. In the real world, maybe it is. You want to solve the problem for a customer or yourself. But the process. What am I thinking about? How am I approaching this? And the first one right out of the gate really is a simple problem, and there's a super easy way to solve it, but that's not how I did it, partly because, well, we'll talk about that. All right, so I have this thing, and there's many of you that do this as well. I've met so many of you out there that I would consider the Packet A team, the Packet Analysis team. You're out there helping strangers on the internet who you've never met, never will meet, who maybe you were in a flame war with previously over something. Season 2 of The Boys, check that out, it's pretty good. And you spend your free time helping people. I don't know, maybe it's like a pride thing, maybe it makes you feel good, but it's fun to do. And so I've done that with Packet Bomb, Reddit, or is probably where a lot of this stuff comes from. One of the ones today came from there. But I used to put little videos in here, but since it's Zoom, I won't show the videos. But I have this little A-team graphic that's if you have a problem on the internet, and if you can find them, maybe they'll help you solve your problem. The Packet A team, and it goes dun, 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 and there's some machine gun fire. Anyway, that's enough of that. So before we get started, let's level set. Let's talk about process. Everyone that you see present has a process. Many of the things we do are similar. I'm just glancing at the chat. Sorry about the tunes, Joe. I'll sing some at the end if there's time. The process that we use when we approach a problem is similar in many regards. You're going to see a lot of the same things from me to Chris to Jasper to Christian and Betty. You're going to see a lot of the same approaches because we all learn from each other. I sit in the sessions and I go, oh, I didn't think about doing that. That's good. I can use that next time. And we all kind of learn from each other. But you take what works for you and you build a process around it. So I'm going to cover just the basics of what I think you need to do when you're looking at packets in Wireshark. A delta column, if there's one change you make to your profile, to your configuration, is to add a column for delta. Time since previous displayed packet. You want that as a column. Now, I think there was a bug in Christian Landstrom's Wireshark because he had the delta column on the right-hand side. I guess that's a bug in Wireshark. I'm not sure. That's a joke, folks. Delta column you absolutely have to have. We're gonna look at delta columns. So the time between things are happening on the network. You're keying off this so many times. It's absolutely critical. When I get a PCAP, especially if someone hands me a PCAP, because I'm not really taking PCAPs myself these days very often, occasionally, the level of information I get from the person, their level of expertise in taking a capture and localizing a problem, it varies wildly. So I don't know what I'm looking at sometimes or looking for, or if I do, is it in there? And so I like to look at the conversations pretty much right off the bat. And I've said this, many say this, many people are saying, it is a sin not to capture the SYN, S-I-N, S-Y-N. You absolutely must get the three-way handshake when you are capturing a problem, reproducing a problem, whether it's readily reproducible or it's intermittent. You must come up with a process to capture the data that includes the three-way handshake. No ifs, ands, or buts, except occasionally super, super, super long-lived connections like data replication that can't be broken. Maybe I'll allow it. Why? Because initial round trip time, the maximum segment size, the window scale factor, other things are only communicated in the three-way handshake. So you want that. The doctor session today had something about CWR and ECN flags. Some of that is reflected in the three-way handshake. It's just stuff you want to have. And then this is not, this is what I do. I adjust columns and configs as I need, and you should too. But once you get it set, if you're troubleshooting a TCP problem and you get a set of columns and a config that's working really well, save it. Save it as a new config as TCP. And then next time you're looking at an HTTP problem and you get some different fields, save it as a config. I hope you had a chance to go through Betty's class on profiles. You'll find probably no one better to talk about that topic. For me, since I do this sporadically, I tend to just kind of adjust as I need on the fly, which sometimes honestly bites me because I take a column away and forget I did, and it would have been useful to have. So there's that. Ladies and gentlemen, the first case study is about Call of Duty. And I want to say games are applications too, people. I think on the Wireshark subreddit, we have a lot of kids coming in asking how to pull IPs. I assume they want to go knock off a competitor offline, DDoS or something. I don't know. And somehow someone told them, oh, Wireshark. And they come there and say, how do I pull IPs? And we're sick of it. We have a banner at the top that literally says, we will not help you pull IPs. It's in the rules of the subreddit. When you hit post, it says at the top, please don't ask this question. Go somewhere else. However, so everyone has a knee-jerk reaction. The people who actually are there to talk about Wireshark has a knee-jerk reaction. Anytime someone posts about Call of Duty, I get a user report against the rules. Well, this guy in his topic, he said something about analysis. I was like, I took a look at it, and the guy did a lot of troubleshooting for some disconnects. He's trying to understand, and he said, as a last resort, he took packet captures. Maybe you've heard that. Maybe you've said that. Well, and he needs help. He's not a super pro at this. He knows the basics of home networking, setting up gear, IP addresses, but he doesn't know much beyond that. So he said it disconnects at random times, or he said it disconnects. And he had a PCAP. And so I could have said, all right, let's go look at the PCAP and see if we can figure it out. I encourage you very strongly to resist the temptation when you get a PCAP to go dive in. We're all guilty of it, especially when you gain confidence with Wireshark and you start to solve some problems. You're like, yeah, I got this. I can do this. Well, that is pride speaking, and pride cometh before the fall. Please, please, please resist the urge and ask questions. So I said, well, is it just this game? Are there other games? Does it happen every single time you play? Does it happen at the same point after you start the game? No, it's at random times, he said. 10 seconds to 30 minutes, maybe, I don't know, 10 minutes, whatever. Does it affect, can you get to websites okay? Are there other problems in your home network, disconnects, things you're seeing? Because this information lets you know, lets you characterize the problem better, so you kind of know what to look for. Because if this is an application problem, a Call of Duty application problem, I don't know what I can do with that. I doubt many of you are looking at Call of Duty all day, packet captures and trying to solve problems. I doubt not many people are. I don't know that that's a spec that is documented. But this applies to other maybe business applications that you don't have good visibility or documentation into. If it's at that layer, you may be in trouble. So it helps you characterize what the problem is. So he said, yeah, sometimes websites don't work either. Well, what he said was, for the first 10 minutes, I can't get to Google related sites. That doesn't make sense to me, but it's a clue. It's a clue. So he gave me not really a PCAP, it was an ETH file. Oh, and he couldn't take the PCAP on his Windows PC because Call of Duty will crash if it sees Wireshark running because it's considered a cheat. I have not tried that to verify it, but I've seen it documented, or I've seen people talk about it. But I did test running dumpcap, and you can run that just fine. So he ran this on his Fritz box router, which I Googled that. It actually looks kind of cool. You can run a packet capture on any interface on this thing. So that was pretty cool. So why don't we jump into, enough of the chit chat. We'll jump into the PCAP. So he gave me his PC IP. I'm going to pause just for a second and look at the chat. The thing is for gamers who are losing to DOS the server. Okay, yeah. I've seen a couple things. People get knocked offline or maybe the server, but they also will just look up the geo information on your IP and kind of freak you out. Oh, I know you live in, Pittsburgh, and your ISP is this. And so I'm looking in your window. Yeah, don't dive in. Pause first. Ask the questions. Be Sherlock Holmes. Ask as many questions as you can. So he gave me his IP of his PC, and then 2 IPs that he guessed were related to Call of Duty, a Blizzard server and a Demonware server IP addresses. So again, he put in some effort, and that's when I read it, I was like, you know what? I'll try to help you out. So as I said, well, capture file properties, I think, is a very useful thing to do first. This looks like it was just a 59-second capture. Oh, guys. So he put this on Reddit. So I don't really have any qualms about sharing it with you. I'm going to put it in the chat. Yeah, so 59 seconds, not almost 9,000 packets. We get what's a little bit of information there, and then conversations. Now, It is as I would expect. Lots of traffic. If this is captured on his router interface, I guess to his PC, all the traffic, right, is to and from his PC. Well, no, everything actually. There are other IP addresses. Let's just call it the LAN interface. So we've got 116 TCP connections, 200 UDP. We've got 170 IP pairs. We've got IPv6. You know, I don't dig into a lot of home network stuff in my life, you know, a little bit occasionally when it's my own thing. I'm normally used to more enterprise PCAPs. So like there's tons of chatty stuff, all your IoT devices and your Xbox and your TV, everything's talking on the network these days. So that just kind of tells me, I mean, I see, we know his router's .1 and his is .54. Let's make sure we have .54 traffic, and we do. There's a good dozen and a half. So that's the other thing, is that when someone describes a problem, if they tell you when it happened or the IP address is involved, if you have this process beginning, verify that the data you're going to need is in the PCAP. Don't waste your time. Okay, so what we'll do, I want to move that out of the way. We'll filter, let's start out by filtering on his IP, I think, because I don't really know, you know, the behavior of, like I said, this application. I don't know what it does. And one thing I don't usually enable, but here could be useful, is just resolve network addresses. You know, maybe something interesting will show up and help us, give us a clue that it's talking to something Call of Duty related. So start off, we have a three-way handshake, so that's good. I'm not gonna dive into, like, since I'm not necessarily analyzing performance, we're gonna have to move since we got a little late start. So this IP address, we could go look it up, but it is a Blizzard server and it is the one he gave. So we know this one is on port 1119 is related. And some, you know, I just kind of scroll through because I know there's a problem ideally in here. We're gonna try to find it. I mean, a disconnect ideally would be, we could be able to spot that kind of behavior, but I'm also just curious what's in here. I mean, here, the Fritzbox, that's his. Then there's an NVIDIA. I guess he's got an NVIDIA graphics card or something. We'll just do a little scrolling. Battle.net, I'm pretty sure that's a Call of Duty thing. And here's another one, Demonware. Yes, he mentioned Demonware. But it seems pretty clean, right? I mean, traffic's going back and forth. We've got new connections. We've got TCP, TLS. Don't see anything jumping out at me. A single one-off dupack, not gonna chase that down. Okay, well, there's a big red thing. This is, what is this? Akamai. It is a ping request and the TTL exceeded. I don't know that that would really be related. Well, it has a TTL of 1. So yeah. I don't know that that is anything to worry about. Maybe he was doing some other, what's too small to view? I'm sorry. How's that? Is that too big? That's a, is this more readable? Yeah, Jeff could be traceroute, right? Let me know if that looks better. Let's go a little quicker. So he's talking to, I mean, whatever happens in the beginning, you know, I mean, I've played the game. Actually, I recently kind of started playing it a bit and I get killed. I take 2 steps and I die. It's very difficult if you've not like grew up playing these games. Okay, so this is interesting. we have this daemonware stuff happening, and then we have a bunch of UDP traffic to 3074 over a bunch of different IP addresses. I believe if you Google it, 3074 is like documented as a port you want to have open to play this game. So I don't know if he's like, maybe he's pinging different servers to find the best response time to join a server. Are these peers that he may be playing with in a game lobby that he might want to knock offline later? I'm not sure. But clearly that's game related. They all respond back with a UDP ping or something, right? So that's going. We're about halfway into the capture. In the interest of time, why don't I scooch down and see if we can actually find a problem, because all this looks fine. And he had the problem and stopped the capture. So it makes sense. It would be near the end, right? But we clearly see now he's sending UDP traffic. He's probably playing this game, hopefully doing better than me. Oh, okay. Let's back up. Okay, so we've got traffic, TCP traffic. And then we see retransmissions from daemonware. I'm going to take this off now. This is better. Okay. So a remote server is retransmitting data to him. Remember, we're capturing on the router, so it's going out the LAN interface towards the PC. So traffic is going back and forth, right? Is this the same server? I think it is. Why don't we filter on this conversation filter TCP? That'll clean it up a bit. Okay. Yes, we have traffic going back and forth, and then retransmissions. Now, if you look at the time, so this is where delta is useful. Delta, is huge in performance analysis, but it's useful in all kinds of places. So we have, to make this easier, I've got a sort of a simple profile layout, but I'm going to add the sequence number information to my columns so I can tell where we are, in the byte stream. That sequence number, and it may get a little messy since I've got big numbers. Let's do that. Let's do center. Okay, so we're retransmitting the same TCP segment. This, we sent no data. It was just an acknowledgement back to the PC. Then we come in, the server sends 322 bytes of TCP data with this 9120 sequence number. Well, it doesn't get acknowledged, which, okay, TCP may ACK every other packet. So maybe the client's waiting for the second packet to ACK. But we see it waited 375 milliseconds. That's probably an RTO, right? That's a timeout. So it retransmitted, it was never acknowledged. It sent it again, it waits for the ACK. At this point, we should definitely see an ACK from the client. It doubles the time, sends it again, doubles the time. Like, these kind of numbers should jump out at you when you look at packets. This doubling back, exponential back off, retransmissions, that kind of thing would jump out at you. And then that's it. We get, clearly this is a problem. So let me go back to this filter. We're going to look at the traffic after the retransmission. So here's where the PC, like the last thing it sent is up here, right? And then the ACK, the data, here's a different TCP connection being reset towards the, but in terms of source, we see this, which is IGMP, right? Multicast. And we see this, which is, these are just membership reports telling IGMP, hey, these are the multicast groups I care about. And there's another one. But other than that, we don't see it send anything else. But remember, we're filtering on IP. We're filtering on layer 3. And there are other protocols. So why don't we go here to the last packet we sent, and then why don't we filter on its MAC address to see source, any traffic that it sent. Apply as filter. Okay, so here we are. And we see, well, it's not a source, it's just a source or destination, but fine. We see its ACK. We see a couple packets from the server, and the next thing we see is an ARP from the PC saying, who has 0.1, tell 0.54. And we get a reply. 0.1 is at this MAC address. So right away, I go, aha! It stopped after it did an ARP. It's got to be ARP related, I think. That's a huge clue. So, I dug into this ARP request and reply. Where's the problem? There's got to be a problem. Couldn't find one. But clearly something happened. And again, we're capturing on the router, on the local, I don't know what the local network looks like. There could be traffic going to his PC that I just can't see. That is a strong possibility. Question is, why is his PC doing IGMP? Is that the same MAC address? That was after this, right? This is it. Yeah, so it's sending it to, his source address, sending it to a multicast destination MAC address. Do I have a window? I think, yeah, actually, if you look, so ARP, right? You have a table. You need to map your layer 3 to your layer 2, the internet address to your physical address. It will time out, and you have to ask for it, and it maintains a table. And it's dynamic. You have some that are static, and 0.22 is one of them, so it doesn't have to look that up. It just knows what it is. So I'm like, okay, something's going on with ARP. I can't spot a problem here. Let's just look at all the ARP traffic. And ARP announcements, and then something's happening here. Scroll over. Huh. That looks suspicious. Don't be suspicious. Duplicate IP address detected for 0.1, which is what we ARP for. And what is this? This is coming from a TP link. I just bought a TP link wireless extender, so I know that it's a network device on his network that appears to have the same IP address. And it's a gratuitous ARP, ARPing not broadcast, but directly to this is the MAC address, I believe, of the default gateway, of the actual default gateway. So I saw this and I said, hey buddy, you got a TP link device in your network configured with the same default gateway as your actual default gateway. When you ARP and ask for the MAC address, I think the way it would work is if the real one replies first and then right behind it is this one, it could update the table, and now it has the wrong MAC address. It's black holing traffic to this TP link device. So he goes and he changes his IP address, and it fixes his Call of Duty problems. It fixes his internet website problems. Did not think I would be able to help with a home network problem, but you know what? We got lucky and we found something. Now, you can also add, I'm not going to go, you could add a coloring rule to this so it jumps out better if you want. I won't go through that exercise just for time. So this was me walking through how I arrived at this conclusion. And I think that's useful, right? The process you go by, you know, looking when it stops talking, what's happening at that time, clear the filter so you can see everything, so you see more information, and then you find this. There's another way you could have found this a little quicker. And there's this big red button down here. And it tells you all the expert infos that are in the PCAP. And there's one right there that would say, oh, that's, that looks suspicious. Could have found it literally in less than a minute. And you will find, clicking on that button, it's not in my normal workflow. Using IOgraph, not in my normal workflow. Christian Landstrom today said, the graphs that I depend on, he doesn't use them. I should, but it's not in my workflow. Everyone has different workflows. Sometimes it can bite you. Sometimes it helps you find a problem super quick. You know, just be aware of that. Okay, so that is Call of Duty disconnects. We're gonna hop onto one more. We'll make it quick. I think this one is pretty quick. This one is more of a business application. You didn't know that was clickable. Oh yeah, stoplight. Yeah, that is called. We call it the easy button. If you click on that button at the bottom, this is a business application. Someone sent to me, my buddy Fidel. We've collaborated on a few things together. So you've got two servers. This is I think a TV station. So this is about scheduling media content that will then air. So you have two servers with two different vendors. You can see where this is going. This ENPS server sends a message, an application protocol. It's called MOS, Media Object Server, I believe is the protocol. It sends a message to a Bit Central server, which then schedules it to go on air, and it should acknowledge it. You know, it's a basic application protocol. Well, at some point, intermittently, working with the vendors to figure out what it was, a message would get sent, there would be no response, and they would disconnect. They have to go reset or like delete the last thing that was sent and then kick it off, and then it would be fine until the next time. And the vendors are like, well, you know, it's their problem. Like, no, it's their problem. And then when they couldn't pin it on each other, they turned to Fidel and his network and said, oh, well, your servers are on different switches and different VLANs, so that's not going to work. And of course, they're right. There's no way to route between VLANs or switches. He humored them, made a change just so they could say no, you know, not hold that over him. Sure enough, it didn't fix it. So he went and got PCAPs. And he's like, you know what? I'm going to go look at this and see if I can figure out what happened. This is it. It is, I think I want this one. And I'm not going to share this one with you. My apologies. I did do some anonymization on it, but it's just IP addresses. It still has data in it. Okay, so this is on the sending side, the ENPS server that's sending the content schedule to the Bit Central server. And just real quick, we'll do our thing. This was like a 30-minute capture, and still not a ton of packets, so only 5,300. And conversations. So there are like 34 conversations, but it's only one IP pair. So it's the two servers in question, right? So now you could, here's the thing. Maybe there's a disconnect, a reset, a fin, and you could go drill in there, and maybe that would help you, but there's 34 TCP connections. Which one was the problem one? Again, this goes back to asking questions, approaching. This is an application protocol I know nothing about, but if you know the basic networking, you know the stack, right? You know how layer 2 and layer 3 and layer 4 work. And in general, application protocols in general, they're passing information back and forth. They're sending commands. And there's usually some kind of application acknowledgement. You know, there's potentially this application protocol is documented on the internet. But I looked at it, it's pretty simple. I didn't feel like I needed to go too deep on that. But trying to find the one that broke could be a chore. If you've ever done troubleshooting on HTTP and there's 25 different TCP connections and they're asking for different things, but the web page froze, figuring out where that happened from a PCAP alone is really hard. That's why things like Fiddler or the development tools work to tell you what objects didn't load, and then you can go look at the PCAP. So he worked with the vendors to figure out what was the message ID. The application protocol message ID is the last one that failed. And that's just a string, right? So that is, you could look at timestamps. Hey, what time did it break? Okay, well, let me go and look and try to match the time and find a problem in that area. That's one way to do it. But if you spend the time quizzing people, pushing for information, being relentless about information, it will help you out in the long run. Spend less time trying to do this. So what we're going to do is we'll do Control F to find. And I'll just type it in. It is, the message ID is 1067608. Now what I want to do is I do want to search for a string. This isn't a display filter or hex, it's a string. And I want to search in the packet bytes, the payload, not this one over here. As you can see me pointing to my screen. Packet bytes, right? And we're going to do a find. And there's a packet, ideally in the packet bytes, has this string of 7 digits. I mean, is that the one we want? Well, we don't know. Could be, but we'll start to look and see. So I'm going to do a right click, and I will do follow TCP stream so I can get the text dump of what I'm looking at. And as I mentioned, I know this is probably small for you guys. My apologies. I'm a new Windows user, so I don't know how to really zoom in quickly without maybe blowing up my whole thing. It looks sort of HTML-ish, right? You've got the beginning of a MOS command with brackets. It has an ID. There's a message ID, right? That's what we want. And then it's an RO story send. So that's probably the protocol command. There's an ID to that. Then there's a story ID, the slug, the num, the body. So again, this is media, right? A news station. And then I think if you scroll down, you'll see just like HTML, it closes it off or terminates it, you know, with a slash at the end of a thing. Yeah. So the payload, the MOS, you close everything off just like HTML. So not super complex. And then the blue is the response, the ID, the MOS ID, then the message ID, and an ACK saying, I got it, done, status okay. So if you're familiar with HTTP, then this is okay. So we're gonna try to find that message ID in here. And it is, we gotta type in the dots, 1067608. And maybe this is it. So let's have a look. This is the beginning of a new message. It matches the message ID, and it's sending information, and it's sending information, and it's sending information. Oh, lots of stories. It must have been a heavy news day. And we get down to the bottom, and there's no blue. There's no response. Maybe we found it. That potentially is the problem. Now, if I click on this last text, it goes to the packet where it exists. Isn't that handy? And here we are. So we can see the server is sending data, full-size packets, 1460 MSS, full-size packets, and then this last one was 722. When you see that pattern, full-size, 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 and then a small one with a push bit, that's an indication that that is the end of a buffer. That's an application indication. The buffer, the data that application was sending, that's the end of a buffer, and now it can be flushed to the application on the receiving end, right? Okay. Then we have a bunch of ACKs, and yes, we have a fin from who? From from the receiver, actually. The receiver waited 10 seconds and fin-acked the thing. Now, the question is this a network problem? Well, one thing we can do, now Wireshark isn't telling us anything that there's packets missing or retransmissions, but let's verify that all the data was sent and acknowledged. So we can do that. If we start like here, this sequence number is 4633. The next sequence number it's going to send is 6093. We come here, 6093. The next one it's going to send is 7553. Now, if we look at the acknowledgement number, it's 0253. That is further up. It's up here. That's acknowledging this packet. So let's come down. 553. 553. 9013. 9013. So all these packets were sent in order. And then we have acknowledgements rolling in. Acknowledged, acknowledged, acknowledged. Wait, where's the last acknowledgement? This is the last acknowledgement before the fin. So the acknowledgement number says, I've received all the data up to and including sequence number 8220. And the next one I expect to receive, sorry, I'm on the wrong field. That was the next sequence number. I've received all the data up to and including 9734. And the next one I expect to receive is 9735. So if we go find 9735, that's the packet it's acknowledging, and it is the last one. That tells me there's no outstanding data. You could also do this with like bytes in flight. Is there any bytes outstanding unacknowledged data? There's not. The data was sent, received, acknowledged. Nothing happened. It didn't send anything back, and it closed the connection. This does appear to be a problem. It doesn't seem to be the network. However, if this is the sending side, well, what if the other side tried to send it back and it never made it? Unlikely, but we can look. He did capture on both ends. Am I using relative sequence numbers? Probably. I turn it on and off as needed, but usually I have it on. No, I lied. Last time I needed to, I turned it off and it's off. Can you try to follow stream viewing as UTF-16? If it works, the packets are twice as large. Oh, it's Gerald. Hello. Let's try that. Follow TCP stream and view as this one. Oh, is that what you wanted? I can't read that. All right, we are running tight on time. Okay, so yeah, Chris, you pointed out you don't really need, you can do the sequence number analysis and know that you're not missing anything. But if you're explaining to people who complain that you had your servers on different switches, maybe you need to verify with them and show them it was never sent. So you take this data back to the servers and you go, guys, here's the problem. I've had to do this a number of times with customers and vendors, and let's get everyone at the table and let's walk through this and let's explain what's actually happening so we can stop pointing the finger at each other. You received a fairly long message and you did not ACK it. The application layer did not ACK it. TCP ACKed it. The application didn't. And after 10 seconds, it closed the connection. Does that ring any bells for anybody? And the guys go, oh, well, there is a 10-second timeout. Okay. So it was taking more than 10 seconds for the receiver to receive this large message, process it, and acknowledgement. So you could say, well, you could say that you need a bigger server, spend thousands of dollars, beef your server to process it faster, or you could increase the timeout to like 30 seconds and move on. And that's what they did. Okay, folks, that was a fun one. This is, real world business application using the packets to show where the blame is. It is David S. Pumpkin Seasons. If you have any questions, put them in the chat. Give me 2 seconds. thirsty work. Okay. I hope everyone had a fantastic Sharkfest. Oh wait, don't need to check. Can you please repeat the thought process for TCP packet? Yes. So again, you thinking about the layers, the stack. TCP's job is, it doesn't care what data is being sent, what the application is. Its job is to send a chunk of data and have it be received to the other side in order to hand it to the application. So it sends a chunk of data and that gets acknowledged, and it sends more data and that gets acknowledged. All the data that the application tried to send was sent and acknowledged. Great. Now the onus, the responsibility for anything new to happen is on the application. It's to send more data. So the way the protocol works is it sends a request, it gets processed, and then it acknowledges and says, hey, it's all good. Or maybe an error, like HTTP, right? You do a GET, you get a 200, you get a 404, you get whatever you get. And the application normally send a request, get an ACK back and a status code. In this case, it sent the thing and never sent anything back before closing the connection. So two separate things, TCP versus the application. Whew. It's hot in here. It's a hot day in San Francisco, and I closed all my windows to keep the noise down. Got bright lights on, studio up and running. Is there no better way in Wireshark to match up sent packets and ACKs than manual? I bet there is. I bet there is. I know there's some diagrams like, oh boy, someone probably knows. Drop it in the chat.
Kary, sometimes what you can do is click an ACK and then it'll checkbox, or it'll check mark the packet that ACK is ACKing over on
the yeah, right there. Look, checky check right there.
Which is kind of easier.
Yeah, and I think, isn't there like a diagram type situation that kind of shows you, is it a flow graph? Does that do it? Don't know.
Also, there's an ACK4 in the header too.
Yes, yes, yes. Where is that? Is it here?
Yeah, there you go.
This is an ACK to the segment and frame, yeah.
Which is the same as the check, but anyway.
Yeah, but yeah, and like to me, when if we're thinking like a visual way to do it, in Wireshark, I'm not sure what else there might be. So I'm not sure what the flow graph is quite telling us. I've not really used it. Like if there were something unacked, would this look different? How about we go look at the other? I think I still have the other PCAP up. We'll go down to those retransmissions. This, and I guess this will show me just that flow graph. Where'd it go? Ooh, that's interesting. That's more interesting. Oh, but this is everything. This doesn't. Here we go. Limit to display filter. Maybe? I'm not sure it tells you which packet is being ACKed in this. I'd have to spend a little more time digesting this with my eyeballs and brain. Yeah. Please fill out the survey. You can email me if you have case studies. I mean, I don't really come up with these, right? These are people who contact me, and either they solve something and they want, hey, does this make sense to you the way I solved this? Do you agree? Which is what this one was, this Moss one. Fidel solved it. He was just asking for confirmation or just some feedback, and he nailed it. Or if you're stuck, need some help, you know, my turnaround time is, you know, whatever it is, but I'm happy to do it. If, you know, if I can turn a case study into it. If it's like a big deal, then I will refer to you to someone like Chris Greer. Twitter, packetbomb.com. Yeah, I appreciate you guys doing the live streams. This been my little project, building a PC for the first time in 20 years, doing live streams on YouTube on my channel. I've had Chris on, Hans on, Jasper. I mean, we've had, I've done a few of my own. Betty's on, Saki's been on. Check out the latest one from Phil's story. I mean, this is a Wireshark conference, but I think people talk about other tools. There's a tool there we looked at called Net Data, which actually probably Jeff would, it's all visualization. There's no like looking at packets, but it's one dude who spent 20 years doing this kind of work, and he built his own tool. It might do some visualization on the ACK thing. Yeah, but you know, this is, yeah, I think one thing I didn't mention, but you guys should know, I mean, for Wireshark, it's a specific tool for a specific job. If you're wanting to look at, you know, what's my bandwidth for the day on my network, that's not what Wireshark is for. I think of it as a scalpel to really drill in and understand, because like I said at the beginning, those 5-minute S&MP graphs, there's so many problems. They're just not, they have no use. They're not going to help you. And you've got to look at this level, this level, the packets. And I mean, there's just such a fantastic community around Wireshark and so much knowledge out there and people willing to help and share. I'm happy to be a part of it. So thank you to Gerald and Sherry and Angelo and everyone who helped put this together. I can't wait for us to hopefully, knock on, be back together next year. Yeah. Anything else? We're here at the time. I think there's a closing session.
Nice job, Kary.
All right, sir. Hey, thanks, Chris. Appreciate it. We got through it. We did it. All right, now I guess I'll sing some songs for you guys since we couldn't play 80s.